everyone, welcome to my YouTube channel. This is Unit 1 Electrostatics, and the topic we are going to discuss is to find the energy stored in a parallel plate capacitor. We will also talk about the energy density, but first of all, let us step into the article in order to find the amount of energy stored in a parallel plate capacitor. As we all are aware that in order to find any kind of energy, we need to calculate the amount of work done, and for this purpose we only know the equation, that is work done is equal to force into displacement. This equation is already discussed in class 11th and in class 9th, but here this equation is not going to work, so we will have to think about the other equation which is really going to help us out in order to find the potential energy or the total energy stored in a parallel plate capacitor. So in electrostatics we discussed various terms, that is potential, charge, capacitance, but here we will talk about the term that is work done is equal to potential multiplied by charge, that is W is equals to QV. So this was the equation which we already have derived, so we will make use of this equation, and we already have this equation in terms of differential, that is dW upon dQ is equal to V, or we can say dW is equal to V dQ. So this is the equation which is really going to help us out in order to find the energy stored in a capacitor. Let us mark it as equation number 1, and now we have to find the total work done in order to find the total energy. So in order to find the total work done, we have to integrate this equation. So we know that W is equal to integral of dW is equal to integral V dQ. So this is the equation which we are not going to use as it is, because we have to think about the capacitor as well, and we know that charge stored in a capacitor Q is equal to CV. So instead of writing capital Q, I will take small q because I have taken dq. So we have from this equation V is equal to Q upon C. So this is the equation which is really going to help us out. This equation 2 could be substituted in the above equation, that is W is equal to integral V dQ. So in by putting this value of V in this in the above equation, we have W is equal to integral Q upon C dQ. So this is the simplified equation, but we just need to integrate this equation, and we are already aware about the rules. So let us take the capacitance of a capacitor C out of the integration. So we have W is equal to 1 upon C integral dQ. So now we need to recall the various rules. So we had the rule of integration, that is integral x raised to power n dx is equal to x raised to power n plus 1 divided by n plus 1. But here in this equation we have x is equal to q and we have n is equal to 1. Therefore, on substituting these values, we are having W is equals to 1 upon C integral, we will not take the integral, but we will solve the equation straight away, that is Q raised to power 1 plus 1 upon 1 plus 1, or we are left with 1 upon C Q square divided by 2, and this work done is stored in the form of potential energy. Therefore, rewriting this equation, we have U is equals to half Q square by C. So this is the equation number 3 which we are having with us, and this is the first form of energy. So we can express this equation into various other forms, and in order to express this equation into various other forms, we again have to consider Q is equal to CV. This is our equation number 4, and we will put this equation Q is equal to CV in the equation number 3, and we will get U is equals to 1 by 2, and instead of writing Q, I will write CV and put whole square divided by C, and this equation is further equal to 1 by 2 C square V square divided by C, and we can cancel out 1 C. So we are left with U is equals to 1 by 2 CV square. So this is the equation number 4 we are having, and this equation is the other form of energy stored in a capacitor. This is the equation number 5, and now we can also express in this equation in some other form, that is C is equals to Q upon V. So using this equation, that is C is equal to Q upon V, in equation number 3 we will be left with U is equals to 1 by 2 Q square. We will take Q square as it is, and instead of writing C in the denominator, I will put the value of C, that is Q upon V. Now we can rearrange this equation. So we will be left with U is equals to 1 by 2 Q square V divided by Q, and we will cancel 1 Q, and we are left with U is equal to half QV. So this is the expression number 6, which is the other form of energy stored in a capacitor. So that means we are having 3 different equations, that is equation number 3, U is equals to half Q square by C, equation number 5, and equation number 3 where Q is representing charge and C is representing capacitance. That is, this equation is in terms of charge and capacitance of a capacitor. Then equation number 5 is half CV square, where C is capacitance and V is potential. That means we can use this equation when we have capacitance and potential. And the sixth equation, that is C is equals to half QV, which is in terms of charge and potential. Again, so we can make use of these 3 different equations in different ways whenever required and as per the information given. So moving forward, now we will talk about the charge density or energy density. We will talk about the energy density. And in order to find the energy density, we should know the definition of the energy density. It is always expressed by small u. So small u, that is energy density, is the ratio of energy stored in a capacitor to the volume of a capacitor. So energy stored in a capacitor divided by volume of a capacitor, V. So let us mark this equation as equation number 1. Now what we are going to do, we will write the equation for the energy stored in a capacitor, and then we will write the value of volume. So energy stored in a capacitor we have already calculated in the previous article right now. So energy stored in a capacitor, capital U, is equal to half CV square. So I'm not going to make use of this equation straight away. I will make some changes in it, and I will put the value of V is equal to ED from the definition of potential gradient we already have discussed. Therefore, we have U is equals to half C, and instead of writing V, I will put ED and whole square. So the equation will come out to be half C E square D square. Again, I am not going to make use of this equation in equation number 1. I will make some more changes, and I will put the value of C, that is C is equals to epsilon naught A upon D. Therefore, above equation will turn out to be U is equals to half epsilon naught A upon D, writing it in the bracket so that there should be no confusion, and E square D square as it is. Now we can cancel out D over here. So we are left with U is equals to 1 by 2 epsilon naught A and into E square D. So this is the expression we are having for the total energy stored in a capacitor. Because I cannot simplify it further, so I will mark it as equation number 2. And now I need to find the value of volume. So just recall the definition of the volume, which we have already learned in the various classes, that is volume is equal to area into length. Here we are not having length, we are having the distance between the parallel plate capacitors. So we will mark volume is equals to A into D, and we will use the equation number 2 and equation number 3 in equation number 1. So we are having now we will be having U is equal to small u, that is energy density, is equal to, just look at the equation number 1 once again, energy stored in a capacitor, which we have calculated, half epsilon naught A E square D. So half epsilon naught A E square D divided by volume. So it is divided by volume. So volume, we have written A into small d. So A into small d, we will cancel A and we will cancel d. So we are left with energy density is equal to half epsilon naught E square. So this is the equation number 4 and the expression for the energy density U. It is not called charge density, as I told you previous. It is only called energy density. So this is all about energy stored in a capacitor and energy density. And I hope you have understood these articles. If yes, then do not forget to press like, subscribe and share button, and do press the bell icon in order to get latest notifications on